Hey, in this video I'll give you an explanation of what dependency injection is. This pattern isn't language specific, and you may find it in many popular frameworks. We'll see how it can be used in Go for developing microservices and consider examples with open source tools, so some basic familiarity with Go language is required. First things first, let's properly understand the problem. It's well known that a global state in a program via global variables is a really bad practice that prevents you from writing easily tested and modular software. So typically, we use state encapsulated in instances of structs or classes in object-oriented programming paradigm, or even closure variables, and this leads us to use one instance inside another to get access to this state or behavior based on it. So, it's common that one type depends on another. For example, service depends on a database connection pool. To make code loosely coupled, one needs to use the most abstract way for each dependency description. In the case of Golang, it's an interface with specific methods. This leads us to a dependency graph that's in a cyclic directed graph. So, the best way to describe all dependencies for a given type is to provide a constructor function for it that depends on other types described as constructor arguments. Let's consider a simple example of an HTTP microservice consisting of several modules. I'll give you a link for the code in the description of this video. For the sake of setup simplicity, we use Postgres running with our app via Docker Compose and populated with sample data. We will focus on build manually function that creates app instance. It already follows described ideas, but uses manual dependency injection, when you pass instances to constructors and create new instances by hands. Let's run it to check that it works as expected. Our app has a quite simple type dependency graph that can be represented in one slide and omits implicit interface to type matching. It's okay if there are only 10 constructors for types, but what should you do if there are 100 types and each one of them may depend on several others? The intent behind dependency injection is to achieve separation of concerns of construction and use of objects. Also make construction of them as easier as possible. So we want to go a little further and provide you with two ways of automation for this code based on Golang runtime reflection and on precompile time code generation. In the first case, we use an open source uberdig library that uses runtime reflection. All one needs to do is to register constructors via library provide function for each type and specify interface bindings, because implementation and interface, strictly speaking, are two different types in Go. Here is a classic way of dependency injection, and it's described in build runtime function. You ask the dependency injection manager to invoke a specific type instance, and under the hood it investigates via reflection in runtime the dependency tree and builds all the dependencies for you. Let's check all works as expected. In the second case, we use precompile time code generation via Google Wire library. One needs to create a special file for generator name wire.go, where declares all constructors and interface bindings. This file doesn't contain any real code, because it's defined only for wire inject build flag. After that, one needs to generate the code via a special command line interface, which eliminates the need to resolve dependencies manually. Code generator parses signatures of constructors on precompile time, so there is no runtime overhead, and creates for you build compile time function. It's similar to build manually function we have seen before, but it's generated by Wire tool. After that, we need to replace build in runtime with build compile time function. Let's check All works as expected. In both cases, you are fully abstracted from where the dependent type instances came from and just implement one type only, separated from the creation of others. Thus, dependency injection will simplify the unit testing process when all you need to do is provide a constructor for mock type that implements some mocked interface. But if you prefer, you can pass mock instances manually because they are described as interfaces and not concrete types. Now you understand what dependency injection is and how to use it for building microservices on Golang. While working with a large codebase, this technique will make your code more loosely coupled and simplify dependency management between different types. I hope that once you use this technology, you will forever become its evangelist. If you or your company are interested in consulting and training on various development and infrastructure topics, you can contact us via the email address provided in the description. Don't forget to subscribe to our channel and press the like button. Thanks for watching.